Hi team, this is notes number 9. Today we're talking about rate of change and slope, and you guys already chatted with us about what we already know, so you should already have this section filled out. If not, you can write what you know about rate of change and slope. So you're probably here because you need a little bit of support, and so we see a bunch of different things. On the front, you should see how to do it from a table, and then how to do it from a graph. Then we're going to talk about the average rate of change when something's like not specific forever. And then we'll take a look from individual points and then again from a graph that is goes positive and negative. So we're going to start on the front here. It says from a table. It says the table shows the number of miles a plane traveled while in flight. Use the information to find the approximate rate of change, right, in miles per minute. So they give us a really good clue right here, miles per minute. That means we know that we're going to need to have miles on top and minutes on the bottom. That helps us because that means, remember, we always want to have the change of y over the change of x. So if I'm looking here, my x is going to be my time, and then my y is going to be my distance. We almost always put x on top and y on bottom, in a table like this, but for our rate of change, we have the change in y, or the rise, over the change in x, which is the run. So if you're thinking about it like this, rise over run. So I'm just going to check out, I'm going to pick one of these boxes. I know that it increases 30, 60, 90, 120, so they're equivalent increases. So I would say that my time is changing by 30 minutes. All right, so 30 minutes is how much it's changing by. From the 30th minute to the 60th minute is 30 minutes. And then my distance, it's going from 290 to 580. I'm not 100% sure what that is, so I'm going to go ahead and go over to Desmos. Where are you at, Desmos? There we go. And you can do this on your calculator too. So I have, let's see, here I'm going from 580 to 290. It's 290. So I could check the other ones too. I'm like, okay, if I'm going from 580 to 870 minus 580, it's still at 290. So I'm going 290 miles every 30 minutes. And then I'm going to keep using my calculator. 290 divided by 30. I know that that's the same as 29 over 3. Divide by 10 on top and on bottom, which is the same as 9.66 miles per minute. So in 1 minute, it's going almost 10 miles in 1 minute. Pretty fast. So that's how we do it if we have a table. If you're looking for a graph, we can do the same thing here. So this graph represents the distance traveled while driving on a highway. So I see on my x-axis is my time, and on my y-axis is my distance. And it says use the graph to find the rate of change in miles per hour. So I'm going miles per hour. So I see that I'm going up 60 miles, right? So if I start at 0, I'm going to 160. That means that I've gone up 60 miles. And in that amount, it took me 1 hour to do that. That's pretty simple. 60 miles per hour. So that'd be 60 miles per hour. Normally we abbreviate to MPH. Right? Pretty simple. Let's say that I hadn't used to that point. Let's say I had chosen this point instead. I could say, okay, start at 0. I'm going to go 120 miles. And it takes me 2 hours to do that. I could still simplify and get 60 miles per hour. So if it's a linear function, if going in a straight line, of course we can use any point. So that's if we're going in a straight line though. Let's say, so like something's changed, and like a lot of times when we're in the real world, the rate of change is not constant. It doesn't always go up the same amount. And so we'll describe them using the average rate of change. So they'll talk about over a specific interval. So they'll tell us like from this time to this time, and they'll ask us about the change, which might be different from another time. So for example, in 2004, 56,878 students applied. So 56,878. That's how many students applied to UCLA. Boo, UCLA. Just kidding. And then 2006, 60,291 students applied. Right? So we don't know for sure that in the middle, like during 2005, we wouldn't be able to say like exactly how many people did, right? Because we know that like that number could be a little bit different. Like it might be somewhere in the middle, but it could be something different. But we could say the average rate of change between 2004 and 2006. So they tell us find the average rate of change for the number of students applying for admission from 2004 to 2006. So this is like students per year. Right, so how many students, how many more students were applying in 2006 than in 2004? So if I'm thinking about the change, I'm thinking about the change in students. So I'm going to go back into Desmos here for a calculator. And I know that my change in students, I'm going to have to subtract. Oop, and Desmos is frozen. Great. Let's try this. Nope, still frozen. Okay. Well, we'll get out of there. I could do this the long way. Let's say 60. I'm sure you've already done this on your calculator, so you don't even need me. I'm going to show how terrible my long subtraction skills are. 8 minus 7 is 1. This becomes 59. 12 minus 8 is 4. 9, 3. All right. So 3,413 students more applied 2 years later. But it did take 2 years to get to that change. And so I'm going to go ahead and divide that. Oh, this is tough. Let's see. It goes in there one time with 1 left over. 7 goes in there no times. 6.5. Don't worry about how I did that. I can teach you if you want. So this would be 1,706.5 students per year. We don't usually have 0.5 students. So you could like easily say 1,707 students per year. All right, so every year they are adding that many people to their applicant pool. So pretty tight. Sweet. Keep going if you're still stuck or if you want to check out from points. So that's like the more like real life situations. Sometimes they just give us points though, and they want to know what the rate of change is. So a couple ways you can do this. First way is you can actually like graph it and be like, okay, -4 and up 3. This is like somewhere like right here, and then over 2 and up 1, 2, 3, 4, 5. Put that there. Careful not to draw extra dots. So then I could check my rate of change here. I'm going to go up 1, 2. So my change was 2 over 1, 2, 3, 4, 5, 6. 2 over 6, which would give me 1/3. That one's like a little funky. I would say that like this can sometimes get messed up if you miscount your little dots as you're going. So what I could say is, okay, I know these are my X's. I know these are my Y's. I know that I'm looking for how much the Y changes and how much the X changes. So the Y is going from 3 to 5. I know that that's changing 2. And the X is going from -4 to 2. So I know that that has to go from -4 all the way back to 0. That would be 4. And then 2 more. That would be 2. So I'd have 2 over 6. And I can simplify that again to 1 over 3. So you can kind of eyeball it that way. That's like the first way that you could try. The second way you could try is sort of eyeballing it or counting. The third way, which you guys are probably super comfortable with, is this like m equals y2 minus y1 over x2 minus x1. And you like type in all the numbers. You put in all the numbers and you do the division. What you're going to find is it's exactly the same as what we did here. We just did it a little bit more in our heads for the second way of doing it. But if you want to do it this way, you can. This would be 5 minus 3 and 2 minus negative 4. It's going to give us 2 over 6. Same, 1 over 3. So 3 separate ways of doing it. One might make more sense to you. So jump in the way that you like it. From the graph, we're just going to pick 2 points. So they already even put 2 points on here. And I'm going to say I know it's my rise over run. My run is always moving from the left to the right. So my rise, I'm going down 1, so that's negative 1, and then over 1, 2, 3. Negative 1 over 3. I can see that the same thing happens. I go down 1 over 1, 2, 3 if I chose those points. If I go down 1 over 1, 2, 3 if I chose those points. Even the same if I chose like the big points here. Let's say I started with this point and I went to this point. I would go down 1, 2 over 1, 2, 3, 4, 5, 6. So that'd be down 2 over 6, which still simplifies to 1 over 3. Those are our quick notes for notes 9.